So I left you with this exercise here to represent the following in the frequency domain. And we see we had two terms, one a cosine term and one a sine term. So to plot this in the frequency domain, the first thing we're going to have to do is to turn the sine to a cosine. And remember we said that we had represent cos. So if we've got sine x of t, then cos x, that is equal to cos x of t minus pi by 2. So we're going to have this pi by 2 is going to be a phase shift, and that comes about because of this quarter of a cycle shift between sine and cosine. So if we look at the solution here and what comes out, we see that we've changed our sine to a cosine by putting our minus pi by 2 phase shift in here. So when we come to plot this out, we need to look at our terms. So our first one here, we have an amplitude of 4. Our frequency is going to be 60 Hertz, and we're plotting on a Hertz scale. I should put Hertz on these two here. And here we have a plus pi by 2 phase shift. So our first term is going to be at a frequency of 60, and we're going to have an amplitude of 4 that comes about from this 4 at the front here. And what we have to do is on our phase spectrum also draw a line that is from 0 to pi by 2. Now, because our scale goes from minus pi to pi, that's going to be halfway up this positive half, pi by 2, and we draw this line. So we have amplitude against frequency at the top and phase against frequency at the bottom. Now, our second term is slightly more complicated, only slightly, because we have pi by 2 pi f is equal to our omega naught. Well, this term here is omega naught. So to turn it into f naught, we need to divide it by pi by 2, which gives us a frequency here is going to be a 50 Hertz. So now we're drawing our frequency at 50. Our amplitude is going to be this 8 here, hence 8 here. And we've now got a negative pi by 2. And so in our frequency spectrum, again at a frequency of 50, we have an arrow going in the negative direction that's halfway down between 0 and pi on this negative half of the spectrum here. So that's how we would draw out the frequency spectrum from that equation. Before we carry on, I just want to remind you of two trigonometric identities, because again they're things that come up. So occasionally when we multiply two cosines together, or square cosines, we'll either get cos squared or sine squared. And we have to remember these identities can be very useful to allow us to plot them out, because we know how to plot a cos, but plotting a cos squared is rather more difficult to work out. So, just on that identity, I'm going to give you another little exercise. How do we go about representing in the time and frequency domain this equation here?